Okay, so let's take a look at these last couple problems here. So, uh, I might probably just skip over all the many different ways you can do these problems and start to look at some of the more efficient way of doing these problems. So let's go back and look at number 17. Definitely the way that we'd want to do this one. I won't bring Boromir back in here, but we can just set this one equal to 0. So let's go ahead and add the 28. Put it over here on this side. When we set that equation equal to 0, we're in business. Because then we can go back to some good old factoring tricks that you've been doing for quite some time now. Two numbers whose product is 28 and their sum is 11. That's got to be a 7 and a 4. So you have x plus 7, x plus 4. Doesn't that mean that x plus 7 could be 0? X plus 4 could be 0. So solving for x could be negative 7, and x could be negative 4. Done deal. Awesome. Just please keep in mind that all those other different ways that we could have solved the problem, graphing, quadratic formula, all of them could have worked here as well. Looking at number 18, this one here can't take out a GCF. So this would be the one if you wanted to solve it by factoring. Take that 2 times that negative 3, so now I'm looking for a product of negative 6, sum of positive 5. I think we can do that if we have a positive 6 times a negative 1, and then a positive 6 minus 1, and then don't forget, because this is a 5x right here, we can get 5x by taking 6x and minusing 1x. So we can rewrite this guy as 2x squared plus 6x minus 1x, and then minus 3 equals 0. Group, I'll use brackets to stop myself from foiling again. See how I put that bracket behind that negative sign? To remind myself to take the negative out when I do my GCF work. And so that's what's going to happen next. Factor out the 2x, leaving us with x plus 3. Here, factor out that negative 1. So I'll write as minus 1. And then I've done that right because look what we have here. We have x and then followed by a plus of 3 equals 0. So now I have 2x minus 1 for one of my factors, the ones that aren't in parentheses, and the one that is in parentheses is x plus 3. Zero product property. I can say that 2x minus 1 could be 0, and then the other one, x plus 3, could be 0. Now this one here, the one on the left, the one on the right, it's pretty easy to solve. All we have to do there is just simply subtract 3 and we're good to go, right? So then x would be equal to a negative 3. There's one solution. The other one here, just a two-step algebra problem. Let's add 1. So then 2x equals 1. Divide by 2. And so here's our other answer, x equals 1/2. Okay, so those are two answers there, which we could easily check. The only other method that I could probably think that you could probably do here relatively painlessly, quadratic formula, you get a decimal, that's okay. Graphing wouldn't be too bad here. Take a look at what happened if we were to try and solve this one by graphing. 2x squared plus 5x minus 3. Let's fire up that graphing calculator. Alright, there you go. 2x squared plus 5x minus 3. Go ahead and hit graph on that. So now we see those two solutions. Now when you go to the table of values and look at the negative, see right there, there's one of them right there at negative 3. Did you catch this right here? See how it goes from a negative 3 to a positive 4? If you really think about it, the only way you can get from a negative to a positive in the y values is if you hit 0 someplace. So your other solution has to be between 0 and 1. Okay? Now what I suggest you do when you go and get that one between 0 and 1 is once again using that calculate feature. So let's calculate that 0. Left bound, looks like I'm already on left bound, press enter. Right bound, arrow up a little bit, press enter again, and sure enough, boom, it's exactly at 0.5. Okay, so now I have my two solutions. And then when it comes to the graph, remember we need Let's get that vertex. Where's that vertex at again? Some negative value there of some sort. So if we go back up there, try and spot some symmetry there. You notice we don't really see a whole lot of symmetry. But you know what? That's okay. Let's try and plot 5 points that fit. And then also plot those zeros that we actually have there. So let me take a picture of this and let's paste that into our paper here, so that way I don't have to look at 2 places at once. Great. So once again, same rules apply. If you wanted to show this by graphing, plot at least 5 points and include the solutions. So because of what we just did with the calculator work, there were 2 solutions. One of them was at -3. So we put a spot right there. And then there was another one at, I believe, 1/2. So put the other one right there. 2 down, 3 to go. So, hey, wait a minute, we already had this guy right there, so how about we just plot the other ones that fit? -2, -5, that one fits. And then -1, -6, that one fits. Don't be afraid to plot more if you need to plot more to make this parabola look a little bit more, I don't know, parabolic. There's a -3. We have a 1 and a 4. Sometimes it doesn't hurt to just plot every point that can fit. You know, if it can fit, go ahead and graph it. And now I got a whole bunch of points right here, which then I can really make a pretty decent looking parabola. With those zeros put in place. But once again, don't forget to write the solutions if you're going to be doing it this way. So you can write that first solution as x equals -3, and then write your other solution as x equals positive 1/2. Okay? Let's wrap it up by looking at the discriminant questions. This one right here, I said discriminant because the discriminant formula, when you look at the quadratic formula, x equals the opposite of b plus minus the square root, b squared minus 4ac all divided by 2a. It's really the discriminant that's right here can tell you how many solutions you're going to have. And if you recall from the work that we were doing from our notes, we actually had a diagram for all these situations. So if the discriminant, the b squared minus 4ac, if it turned out to be positive, that would mean there would be 2 real solutions. If it turned out to be exactly 0, there's only 1 real solution. And if that discriminant turned out to be negative, there would be no real solution. So the way I see it, you got 2 real choices that you can do right here. One perspective, you can actually take the time and do the b squared minus 4ac. So when you're looking at a right there, don't forget, you gotta set it equal to 0 first. So 4x squared plus 4x plus 1 equals 0. So then a is 4, b is also 4, c is positive 1. b squared minus 4ac would then give us 4 squared minus 4 times 4 times 1. When we do that, we end up with 16 minus 16, which gives us exactly 0. Okay? And so then looking at our chart here, since we got the discriminant to be 0, that means that we have 1 real solution. Let's take a look at the other ones. So when we look at that second one, -3x squared minus 9x minus 11, so the b squared minus 4ac, let's go ahead and do that. Oh shoot, whoops. I accidentally typed it into the graphing calculator. Oh no. Big mistake, right? Well, let's look at the graph. Take a look at that. Do you notice that when we graph it, that parabola does not even cross the x-axis? So do we see what kind of description this kind of fits? When we look back at our chart and combine that with the picture of our graph that we have right here, grab that chart, there you are right there, make you nice and large. Looking at that right here, kind of fits this situation now, doesn't it? So wouldn't that mean the discriminant was negative? So now we have a nice little answer here that there is no real solution there on this guy. Okay, so let's get rid of you. Looking at the graph, sometimes you can tell just by looking at the graph how many solutions you have. So don't be afraid to use that right there. That's also in your back pocket. Don't be afraid to use it. Okay? We could do the same thing here with C if we wanted to. 2x squared plus 5x equals 0. Graphing calculator. 2x squared plus 5x equals 0. So I guess I just delete the rest of this stuff. Hit graph. Oh look, I see it crosses the graph, the x-axis 2 times. So since it crosses the x-axis 2 times, looks like we're going to have 2 solutions here now, aren't we? Okay. So there should be 2 real solutions. You know, I noticed I did the discriminant over here with the with A. The only reason why I might have done that is if we go back and look at that one, 4x squared, and look at this guy right here, make sure we set it equal to 0. If I type that into the graphing calculator, 4x squared plus 4x plus 1. Sometimes those parabolas are a little bit too close for comfort, you know what I'm saying? Who knows, maybe it just minusculely crosses that twice, maybe it doesn't even touch it at all. I'd much rather not have you sit here and play this zoom in game and zoom in and try and figure out if it really does cross it twice or once or not at all. Instead, if you feel like it's that darn close, then just go ahead and just do the discriminant business on it with b squared minus 4ac. Okay, so that about does it with this review. If you have any questions, if you're looking at it this weekend, please feel free to let me know on Monday because our test is Tuesday. Good luck, everybody.